Saxon Algebra 1/2, lesson 62, frickin' formula word problems. Remember, frickin' formula technically means fractional parts of a number. I think that's a really boring name. This is the formula that I'm talking about, right? It's when we're taking something that's more than one, like a bag of Skittles, and we're dividing it up according to a fraction, and you're finding out your share of it. Now, word problems in general freak people out, I know, but here's the thing. I think that in the case of these freaking formula ones, I think it's easier when there's a story that goes along with it because you can make sense of it a bit better. So let's try it and see. 5/8 of the gnomes who lived in the magic forest had happy faces. Are you kidding me? It's a story about gnomes with happy faces. How, pray tell, can you not love this? You do, I know you do. Okay, if 840 gnomes had happy faces, how many gnomes lived in the magic forest? Okay, now, John is going to teach us later how to draw pictures to make sense of these. Draw diagrams, if you will, not pictures, because that would be pictures of gnomes with happy faces. It's a diagram. We're going to start doing that now because I think it's easier to understand these if you have the diagram. Here are a bunch of gnomes that live in the forest. Now, we blow a whistle. We're looking down at them, right? This is like a bird's eye view down into the gnomes in the forest. We blow a whistle and grab a loudspeaker and say, all gnomes with happy faces must run north, and all the gnomes with not happy faces run south. And then we draw a dividing line. Now, I just draw it arbitrarily. Is it half and half? I don't know, but I'm just putting the dividing line in the middle. So all of the happy faces are up here, and all of the not happy faces are down here. I don't know what all that includes. It could be grimacing, it could be laughing, it could be screaming. There's lots of options, but all I know is that we're dividing them into two groups, the happy and the not happy. My daughter teaches English online to kids in China through a program called VIP Kid, and she has a student who is, I think he's like 8 or 10. 8 probably, he's not 10. And he seems to be on the autism spectrum. He's not dumb at all, but he is a little socially, he's wired a little differently. And if he's frustrated by anything during the lesson, he will say, not happy. So these are the gnomes that are not happy. Okay, let's find more of the numbers. 5/8 of the gnomes are happy-faced gnomes. So right over here by the group that are the happy ones, we're going to write 5/8. Now, before we go any farther, we know, oh, well, that tells us something about the not happies. They must be 3/8, right? Because together they have to add up to 1. The original group always represents 1, and then 5/8 and 3/8, those are the 2 bits, right, of that. If 840 gnomes had happy faces, 840 have happy faces, how many gnomes live in the magic forest? That's what we're trying to find out. And by the way, I'm just going to write magic here because I think that's an important detail. So now what we're going to do is we're going to use this diagram to help us set up this, okay? This represents the of. It's the total group. It's the original group. It's before we divide them, okay? So all of these words can be used to describe this. This shows us 2 is groups. Okay, we've divided the original group into 2 groups. And we have to pay special attention to which one we're interested in because it also gives us 2 F values, right? For this, when we set up this equation, we could be talking about this fraction of the gnomes, which are the happy ones, or we could be talking about this fraction of the gnomes, which are the not happy. So we have to be careful because this side shows us 2 different is groups and 2 different F groups, and we want to make sure we choose the fraction that matches to the number if we have that information. All right, and we're trying to find this out. So what we can see is the fraction, we're interested in this group. It's which ones, we're trying to find out this number. We don't know anything about the ones that are not happy, so we're going to be interested in using this number for the is and this number for the fraction. So I'm going to set it up now using this formula. The fraction we want is 5/8 of some number that we don't know, so I'm going to call it x, equals 840. See how that works? This is my is number, this is my fraction, this is my of number. If in a different kind of problem we might be using this data, but in this problem we're definitely using this one. We don't want to use 3/8 because 3/8 doesn't match to 840. 5/8 matches to 840. Okay, so setting it up is the new part that's hard. We draw the picture. That helps us sort it out. Now we've got an equation. We solve it. We use reciprocals. We divide, right? This is gone. X equals, let's take 840 and let's divide it by 5. It goes in there once. It goes in there 6 times. And it goes in there, oh wait, I'm sorry, I got all excited. I wrote the answer instead of the number, 8 times. So this becomes 168, and that cancels to 1. And now we have to multiply 168 times 8, okay? 168 times 8 is, you multiply 2. That's the answer you should get when you multiply 168 times 8. It's 134. A word problem always deserves a word by its answer. It's 1,344 gnomes live in the magic forest. There it is right there. Yay! Beautiful. Let's do another one. There's 3 in all in this lesson. P.S. Example 62.2. On Monday, 2 4/5 of the acceptable number of rock badgers took refuge in the mountain caves. If 640 was the acceptable number, how many badgers took refuge in the mountain caves? All right, this one has a fraction that is bigger than the original number, 2 4/5. So this problem takes a different shape. Instead of being one group that gets divided into 2 groups, we have a group that grows. This is the number of rock badgers hiding in the cave. Okay, so we're going to start, that's our 1. This is the rock badgers. On what day? Oh, this is the acceptable number. But on Monday, 2 4/5 times the acceptable number was in there. If 640 was the acceptable number, how many were in the cave? This is, and just like before, this is always our of number or our starting point. And this side, now we only have one number over here. This is our is number, and it also shows us our f number. Our fraction is 2 4/5. I'll write it this way just so you can see it. Our of number is 640 equals x. Our is number, Okay, so of is always on the left, and is and the fraction are always on the right. In these problems where something's getting bigger, we only have one is number and one fraction. So they're actually easier. They're just a little weird to recognize because our shape gets bigger. All right, so now we've taken our fraction, and there's our is number. And we got our of number from right there. Beautiful. Now all we have to do is fix this to make it an improper fraction. It'd be 14 over 5 times 640, and I'm going to make this over 1 equals x. And this is nice because we don't have to do any algebra. Everything's right here on this side. We do need to figure out how many times 5 goes into 640 because we can cancel that, right? 1. 14, that will go in there twice. And then 40, it goes in there 8 times. So this and this cancel, and we get 128 right there. And now we need to multiply 128 times 14. Let's do that, and that'll be our answer. There's my answer. There's the multiplication, how I got it. I hope you can agree with me that doing problems about rock badgers and happy gnomes is way more interesting than just looking at the boring numbers, right? And I don't even think numbers are boring. You know me, I love numbers. But if you can give me a problem about rock badgers hiding in unacceptable numbers in a cave, I'm happy. I'm so happy. Here's another one. So let me check and make sure I lined this. Yeah, I'm good. Every time I move the book, I have to recheck, to flip the page. I like to recheck to make sure you can still see it. Because what if I taught a whole lesson where my book was knocked out of camera frame and you couldn't see it? Wouldn't that be a big fat bummer? I know you would all cry and I would feel bad. It'd just be a bad thing. When the fog lifted, 400 ghosts were spied stalking near the outskirts. Ooh, it's a scary problem. If 240 ghosts were not spied, what fraction of the ghosts was not spied? Okay, this one's a little bit confusing. Okay, when the fog lifted, okay, there were some ghosts. As always, they represent one. They represent the whole group. Now, it's foggy, and we can't see them, but when the fog lifts, the ghosts separate into two groups. There are the ones who were spied, skulking near the outskirts, and then there were some that were not spied. Aha, so this is the kind where we have two is groups, and we're going to have two fractions, and we have to figure out how to use that. All right, 400 ghosts were spied stalking, and 240 were not spied. Okay, now that doesn't tell us anything about the fraction, but it does tell us how many ghosts there were in all, right? Obviously, we can just add those because there are only two choices. There's never a third category. Don't overthink that. That's what I used to do when I was a student. I would always overthink the problems and come up with crazy scenarios. What about the ones that slipped away? So don't complicate it. Okay, what fraction of the ghosts were not spied? Okay, so we're interested in this group. We want to find out the fraction that goes there. So we rely on our trusty friend. We remember that this is always the of side, and this is always the is side. So some fraction that we don't know times the original group equals the is group, and it's this one, not this one. We don't want to know what fraction we're spied. We want to know the not spied. Equals 240. So all we have to do for this one, there's our f. Let's divide it by 640. No fractions anywhere in sight. Okay, So far, so good. I like it. Now, all we have to do is reduce this, right? Let's divide it by 10. So now it's 24 over 64. 8 goes into both of those, doesn't it? If we divide it by 8, top and bottom, we'll get 3 over 8. And that's the ghost, Ghosts, ghost spied. And what I want to train you to do right off the bat is to fill in the diagram. We didn't do that in the first problem, but from now on we want to fill in whenever possible. So we know that, oh wait, this is the not spied. My bad, right? 240 is the not spied. So that means the 3/8 goes down here, but that means it's easy. 5/8 goes up there, right? Because it has to add up to 1. And 3/8 were not spied. Yay, that's the right answer. Okay, so I want you to, John's going to catch up with us and start doing the diagrams soon. I want you to start doing it right away because I think it's a much easier way to organize your answer when you draw the picture right away. All right? Yay! Lesson's over. You survived another one. That takes us through 62. Well played, my students. Goodbye.